Okay, hi everyone. This is our project, Robo Home, and recently, for a very long time, companies have been making many components of our household appliances separately. They make it and they sell it, and we buy it, but they're never really just connected together through, single or wearable components. So what we're trying to solve is this house that we built it's connected via three different wearable devices. Four, sorry. It's a Mile and the Pebble and the phone, as well as our laptop. So we'll be showing you all of that through actually a simple story, because we think storytelling is the best way to show our hack. So we'll begin. We'll first begin by showing you this is our character. It's a 3D printed Pikachu, and the Pikachu is we're gonna follow through his typical day using this house. So the Pikachu walks back, he has a very long day of fighting other Pokemons with Ash, and so he walks to his house and he wants to open it. But how does he do that? So he can actually use a Mile with a simple gesture of your hand. You are able to open the house like this. Nice. So it goes in. Perfect. So now we're actually going to show you how you can close the door of the house using our app, and Katie's going to talk about that. So Katie.
Okay, so let me close the door. So basically we made an Android app that connects to the Arduino here in the back via Bluetooth, and each button corresponds to a different aspect of the house.
All right, and you can show the Arduino. Arco, come over here. So we're using our Arduino with a Bluetooth module, and that's connected to our phone. And we'll go more into detail about that later. So now we go into the house. House is really dark, so we actually want to turn on the lights, and we're gonna use our Android app to turn on the lights real quick. So, nice. Okay, so now the lights turn on. Pikachu goes into his house. He, had a really sweaty day fighting, so he really wants to take a shower. And we're actually gonna be using our smartphone to open the shower handle. So as you can see here. Nice. So, he took a shower, he's done. So now he's gonna go into the sofa, and he's gonna go on the sofa and watch some TV, but before that, we're gonna first talk about how our shower is made.
So for the showering device, we actually 3D printed most of the components for it. So first we have the two cylinders on the side here that's supporting the bucket in the middle, and then on the side here we have a device that kind of holds it in. And then on the other side, we actually have a servo motor, and so what it's actually doing is it's spinning, and it's connected to the Arduino in the back, and so that's what's causing the bucket to fall, clean Pikachu, and then come back up when he's all clean.
Perfect. So now Pikachu is done, he's very clean. He's gonna go onto the sofa to sit and watch some TV. So we're actually gonna talk about how we can control the TV, and Ruthie will go more into detail.
Yeah, so rather using a remote, like people usually do, Pikachu's just gonna go to his Pebble Watch, and then with a click of a button, he's gonna watch himself on TV.
All right, so he's watching Pokemon, really cool. But after a while he gets bored and he wants to pause it, so there we go. He can just use his Pebble Watch to do that. And it's getting late, so he's gonna go to sleep. And what we're gonna do is turn off the lights, okay, and then go to sleep. Moving on to the next day. In the morning, Pikachu gets up. He needs to go to work, so we're gonna turn on the lights. Cool. So he goes to work. Open the door. Once again, this is using our smartwatch.
Dude, this is so good.
Smartphone. Yeah. Goes out. Let's close the door. Perfect. So Pikachu works at his laptop, right? And then over here, we're actually gonna go more into detail about how we're using this laptop to control. As you can see, our lights are not actually turned off. And because he forgot to do that. And he actually wants to check whether he did it or not. So Matthew will actually first talk about how parse works. That is our backend.
So the data is stored on the cloud using parse. So this allows us to share the data between our multiple media devices from our laptop, Mio, Pebble, as well as our Android app.
So the web application is basically created using JavaScript and Parse API, along with using JavaScript SDK, the Parse SDK, and the Arduino SDK that the Parse API offers. So what we have here is the web application. Currently, since Pikachu actually forgot that he turned the lights on, and he doesn't even know that he turned the lights on, what he will do is he's going to check his website, which says lights on, and he does, oh wait, I forgot to turn my lights off. So he is going to press lights off, and what it's going to do is in the actual house, it turns the light off. So even if he forgot that he did not close his lights, he can check it and he can turn it off. So similarly, like for other people, even if they like forgot to close their, let's say, door, they can check on their on the web app, and it's like scalable. So like they can check their web app that they have actually forgotten to perform their task, and so they can perform it remotely from their house.
Okay, so lastly, I guess just to summarize, what we really wanted to show is that, as you can see, all these components are just controlled by a single MCU in Arduino and with a simple Bluetooth module. Now, this is of course a very small model, but just imagine the possibility of using many MCUs and microcontrollers or other types of small computers to control all of your house components. And that way you can use your wearable devices, your laptop, your watch, your smartphone to just control aspects of your house. And you don't have to use two remotes for a TV that only works for a TV and you can't use it for anything else. So that is what we're trying to prove, and that's what we're trying to show here. So thank you.
All right, so we're going to open it up to Q&A again. Does anyone have questions? No questions. Okay, that makes it easy for me, so, okay. Wait, we have a question? Oh, okay. Darn.
So I just have one question, because you guys control a lot of your different household appliances and things using like your Mio armband, your Pebble, your phone, and your laptop. So the laptop obviously and the phone can be used outside the house, right? So why did you guys use so many different kinds of wearables inside the house when it could be more convenient to just like have a phone app that controls everything?
Sorry, okay, right. Yeah, that's a really good question. I think what we're really trying to prove actually is that, yes, you can just use your smartphone or just use your Mio armband or just use your Pebble, but we're just trying to show that there's many different ways to control your house, not just to use a single device. And yes, I think a normal average person can just use one device, but to prove that the Internet of Things is possible, we just wanted to show it across many different devices.
Thank you.
Anyone else? Okay.
Hey, so part of the problem with Internet of Things today and hardware in general is the price of scalability and applications across every single household and getting it to a lot of consumers. So I'm sure you guys have a model on how to tackle that problem. I'd just love to hear more about it. Thanks.
Okay, right. So yeah, I think scalability is a huge issue. I mean, once again, right now what we're showing is just a single house, and for the laptop, we're connected through parse. And wait, one time.
Okay, the thing is, like, for scalability, like, we're showing that we're using only one MCU to manipulate all these different devices. So only a single MCU is capable of doing all these devices. Why don't we use, like, if we use two MCUs, think about how many different devices we'll be able to manipulate. And also, when we have this phone app and this web app, this is scalable even currently because you're not paying that much money for it, and a lot of users can use it at the same time. They just need to put their authentication, and it's one web app, one mobile app that's performing all these tasks at the same time. So it's very, very scalable.
Awesome. Just a follow-up question. So what I kind of meant was the installation of the hardware. So I understand that software is obviously scalable, and that's great. But like in terms of the hardware, the installation, how do you think that would work at scale?
Sorry, I didn't hear that last part. Could you?
Yeah. So how would the installation of the hardware work at scale when you have all these components and the average Joe isn't able to install it themselves? I'd love to hear about that.
Okay, right. So. Okay, I think for installation, if you mean just how to contain all of that and how to maintain it across many different households, right now, as you can see, with a single MCU, I mean, of course, all of our wires are shown here, just because we didn't have time to put it all on a single perf board. But with any electronic in your house, I mean, I think like your lights, everything, the electricity, the wires, they're contained within the walls, and in terms of, I guess, putting the hardware and the wires together, I would assume that that part is, it's doable. You can put it within the scope of your house. Yeah.
All right, I think that wraps it up. So another big round of applause for. Thank you very much. All right, team.